In this video, we're going to learn about hydrocarbons, and our focus is going to be on what's called aliphatic hydrocarbons, specifically the alkanes. So first, let's go take a look at what a hydrocarbon is, the many different types that exist, and then the categories. So hydrocarbons, in the most simplest sense, they're organic compounds that contain only carbon and hydrogen, nothing else, just carbon and hydrogen. There's different types of hydrocarbons that exist. Some are called saturated hydrocarbons, and some are called unsaturated hydrocarbons. Saturated hydrocarbons only have carbon-carbon single bonds in them. In other words, they have the maximum number of H bonded to each one of the carbons. So, for example, here I have C, C, H, 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 H. This is a saturated hydrocarbon. It only contains C and H, and there's only carbon-carbon single bonds. Here, if I have C double bond C, H, 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 and H, I have an unsaturated hydrocarbon because we have a carbon-carbon double bond there. Unsaturated hydrocarbons have at least one carbon-carbon multiple bond. Whether it be a double bond or a triple bond, it's considered unsaturated because now you no longer have the maximum number of H connected to each carbon. In a carbon chain, when you have your carbons connected to each other, you can fit a certain number of H's on your carbons, and it varies depending on where your carbon is located. But the point is that by adding a double bond here, notice that each one of these carbons has fewer hydrogens compared to when I had the single bond that was over here. There's 2 on this carbon and 2 on this carbon, whereas in the single bond there was 1, 2, 3, 1, 2, 3. So hydrocarbons, only C and H. Saturated hydrocarbons, single bonds all around. Unsaturated hydrocarbons, as soon as you see a big C and H chain with a double bond or triple bond or more than one of each of those, you have unsaturated hydrocarbons. So what are the main categories of hydrocarbons that exist? There are aliphatic hydrocarbons and aromatic hydrocarbons. Aliphatic hydrocarbons are hydrocarbons that are straight or branched chains or rings, and they don't contain benzene. So we learned about benzene in the previous lesson. Benzene is this ring structure over here, okay? If you're a hydrocarbon and you contain benzene, you would be classified as an aromatic hydrocarbon. So hydrocarbons that contain benzene are aromatic. But if you're a hydrocarbon, meaning only carbon and hydrogen, and you do not contain benzene, then you'd be considered aliphatic. So aliphatic are hydrocarbons without benzene. Aromatic, they are hydrocarbons with the benzene ring somewhere, one or more benzene rings. Aliphatic hydrocarbons can be straight chains, which means they're a linear structure. They could also be cyclic. They're a closed ring structure. And then within the aliphatic hydrocarbon family, there's 3 different varieties or groups you can have. You can have alkanes, alkenes, and alkynes. And then they have their cyclic varieties. So you can have like rings of alkanes, rings of alkenes, rings of alkynes. So essentially what we just saw is that hydrocarbons can be classified as aliphatic or aromatic. Aromatic contains benzene. Aliphatic does not. Aliphatic hydrocarbons can be straight chain, meaning linear, or cyclic, meaning in a ring structure. And then if you're aliphatic, you can either be an alkane, alkene, or alkyne. The ending there is important because that tells you what type of hydrocarbon you're dealing with. So let's go take a look at this little chart over here. Here we have hydrocarbons. And as I mentioned, hydrocarbons can be saturated or unsaturated. The saturated hydrocarbons are actually your alkanes. So your alkanes, they're the hydrocarbons that are aliphatic that only contain single bonds. Now, your hydrocarbons that are saturated. They are your alkenes, alkynes, and arenes, or also known as aromatics. So the alkenes, they are also aliphatic, but alkenes, they contain one or more carbon-carbon double bonds. So alkenes are the aliphatic hydrocarbons that contain carbon-carbon double bonds, as you can see here. Alkynes, also unsaturated, they are aliphatic. They contain one or more carbon-carbon triple bonds, as you can see there. And then your aromatic, they're also considered unsaturated. They are not aliphatic. They are aromatic instead, and they contain a benzene ring. But they're also unsaturated because they have double bonds, which means that they contain less than the maximum number of H that you could have if you only had single bonds. So one important thing to mention about benzene, we'll go into more detail on it later on. You might remember this from the previous unit, but benzene has those alternating double bonds. And you can draw it in multiple ways. You could do this instead. And there's other ways too, but the main point is that these double bonds, they seem to alternate, switch positions, but they don't. These are actually resonant structures. You might remember that from Unit 1. And so because these are resonant structures, in reality, the double bonds and single bonds and the different structures don't all exist individually. The different structures, the actual structure is an intermediate between all the different structures that actually exist. So sometimes instead of drawing the double bond version with the lines that you see here, we'll draw a little 6-carbon ring like this and put a circle in between just to show it's some intermediate between all the different resonant structures that are possible. That we'll learn in more detail later on, but just to explain what this little point here means before we move on. So let's go take a look at the aliphatic hydrocarbons in a bit more detail and see how they compare to each other. So as I mentioned, aliphatic hydrocarbons, they include the alkanes and their cyclic varieties that we call cycloalkanes. They include the alkenes and their cyclic variety called cycloalkenes, and alkynes and their cyclic varieties called cycloalkynes. The alkanes are only single bonds, and they are saturated. The alkenes they have to have at least one carbon-carbon double bond in it, and they are unsaturated. And the alkynes have to have at least one carbon-carbon triple bond in it, and they are unsaturated as well. And so each of these have their own general formula. So if I gave you a compound, if I gave you a formula for a compound, you could figure out if it's an alkane, alkene, or alkyne using the general formula for that compound. So for example, if I had C3H8, this is a molecular formula. Just by looking at it right now, anyways, you can't really tell if it contains single bonds or double bonds or triple bonds. There actually is a way to figure it out. You can use the general formula trick. So the general formula for an alkane is CnH2n plus 2, where N is the number of carbons. So in this case here, I have 3 carbons. So let's see if that fits the what formula this would fit. We have CnH2n plus 2. You can have an alkene, which is CnH2n instead, because you'd have fewer H's since you have a double bond, or the alkyne, which is CnH2n minus 2. So that's even fewer H's because you have a triple bond now. So if you have 3 carbons, C3, and you have 8 over here, this is definitely not the 2n, because that would be 6. It's definitely not the 2n minus 2, because that would be 2 times 3 minus 2. That would be 4. So it looks like it's a 2n plus 2. CH 2 times 3 plus 2. So that here would be 8. So that's an example of an alkane. The cyclic formula is a little bit different. Because it's connected at two ends, you actually have to remove some H's to make room for that, to make a ring structure. It's still considered saturated, but it's a ring structure with only single bonds. It's CnH2n. And we'll go over that in more detail later. Same thing, pay attention here to the cyclic ring structure for cycloalkenes and cycloalkynes. They're a little bit different. You have to remove more H's to connect the ends of the molecule together to actually make a ring overall. Let's take a look at if I want to make an alkene that had 3 carbons, well, I do C3, okay? And then the formula is H2N, so 2 times 3 is 6, C3H6. Just to show you the work here, C3H2 times 3 would give me C3H6. And if I want to make an alkyne with 3 carbons, I would have C3H. So the way it works is C3H 2 times, so 2N, 2 times 3 minus 4, which is 6 minus 4, 2. So 2 times 3, sorry, not minus 4, minus 2, I should say, because that was a cyclic by accident. Minus 2, so 2 times 3, that's 6, minus 2, 4. So C3H4. And it would look something like this. I'll teach you how to draw these later on, but there's your H's, H, H, and H. So that would be your, could be an example of an alkyne with 3 carbons. So the main point here is that if you have the molecular formula, you can figure out if you have an alkane, alkene, or alkyne using the general formula for each one of these over here. As we do some more examples in the lesson, I'll want you to find some more examples of each of these, the alkanes, alkenes, alkynes, and then write some examples down in the boxes so you're familiar with them. Before we move on to do some more specific problem solving examples, let's take a look at the aromatics. The aromatics, also called arenes, they contain the benzene ring, and the formula for benzene is C6H6, and that's considered unsaturated as well. If you have different numbers of carbons, because you can have variety in your aromatic compounds, the general formula would be CnH2n minus 6. But again, just to show you what the benzene ring looks like, you can draw it in a variety of ways. You can do this, this, and this. They alternate, so alternating double and single bonds. You could also do just move them around here. So put this one here, put this one here, and put this one here. And so those are 2 possibilities. These are resonance structures. But instead of drawing the resonance structures all the time like that, we can simply draw the ring with the circle. Just to show you what it would look like with the actual carbons in there, it would be something along the lines of this. So you have 6 carbons, like that. And then you have let's put our double bonds in. So we'll put one here, put one here, put one here. And so we'd have an H over here, an H over here, H over here, H over here, H over here, H over here. So basically 1 H on each carbon. So that's 6 carbons and 6 H's. And that would be the formula for the benzene ring. So let's go and take a quick look at the different ways you can represent organic molecules. What we just saw in this video here is what hydrocarbons are. We saw that hydrocarbons can be saturated or unsaturated, which basically means saturated, maximum number of hydrogens, only single bonds, unsaturated, not the maximum number of hydrogens, so double bonds or triple bonds. Within hydrocarbons, you have 2 main families. You have your aliphatic ones and you have your aromatic ones. Aromatic have benzene, aliphatic do not. Aliphatic can be the alkynes, alkenes, alkanes. And we saw the difference between all of these different types of hydrocarbons. We saw their general formulas as well if they exist in chain forms. And we also saw their general formulas if they exist in cyclic form. And we can use the general formulas to identify what type of hydrocarbon we're dealing with. And then we saw the same idea for benzene, which makes a compound aromatic. And that's a bit simplified. It's a bit more complicated than that, but for now, that's what we'll stick with. In the next video lesson, we're going to take a look at different ways to represent compounds, and then we're going to go apply some of that learning to some practice problems.